A large model Showman'S engine, part 49, bits and pieces on my workbench and working on water piping problems. A friend of mine who lives just down the road turned up the other day with quite a lot of interesting bits and pieces in his car boot. A friend of his had died at the ripe old age of 94, so the workshop was being cleared. Quite a lot of the parts, generally speaking, are quite useful to me, such as the copper pipes and bits of metal, as well as quite a few BA and ME type taps. But some of these bits and pieces I don't want, namely the two locomotives. This is the first one. It's an 060 tank engine, almost complete and ready to run on air. I tried it on air, but it doesn't actually turn because the timing's out, I think. This is a 3.5 inch gauge engine. It's quite small. It could be either a Great Western Pannier tank or it could be an LMS Ginty. I really don't know. It's complete with a fully fitted braking system and most of the hard work's been done. What you're seeing here as part of the collection is a boiler kit, and these tubes are going to be very useful for some of the jobs that I do. And look at this. This is a stainless steel grate, actually a built-up stainless steel grate. Oddly enough though, the main shafts that hold it together are not stainless steel. There's even a roll of proper multi-core lead solder. Here's a collection of random taps, some are BA sizes, some are ME sizes. And I almost forgot there's this as well. It's a 460 type locomotive, part finished. I'm not sure what this is. The name Goodwin is on the cylinder castings. I'm open to offers on both of these locomotives. Offers are invited from any of my Patreon supporters on the $5 or above tier. You can bid on either one or both of the locomotives. Please do not make bids in the form of a comment. Instead, send me a message via Patreon, thank you. And I think because of the weight of them, this offer is only practical in the UK, because of the very high shipping costs to send them out of the country, not to mention import duty. The engineering standard is not exceptional, but it's quite good, and it could save someone who wants to build a good quality 3.5 inch gauge locomotive quite a lot of time. In with the collection was this. It's a 12 volt Bosch motor designed to drive the attached pump. The pump was plastic and no use to me, so I removed it, but the motor's very good. Time to do some work. This is a small acid bath on the bench. Ideal for dissolving small rodents or even dead budgies. But I'm using it to thoroughly clean the inner parts of the injector, which doesn't work properly when it's fitted to the engine. So it's in the acid bath being cleaned. 24 hours later, I took it out of the acid bath and put it into a tub of water right next to it. I've drawn a bit of a blank on why the injector doesn't work. So obviously the injector is my first port of call, but then there's this old gas tap, and even though I've put some O-rings in it to seal it, this may be leaking. Or this nice elbow that fits into the tank via this flange may also be leaking. So I'm going to dismantle all the fittings and improve them before putting them back together. And the first thing I'm going to do is remove all of this horrible PTFE tape. PTFE tape is very useful if the threads don't fit together very well, but I prefer the liquid Loctite 542. I'm also considering fitting this filter to the end of the inlet pipe. I'll need to modify it because the fitting is far too small. The first thing I want to do though is put it into this bath of water just to make sure it's rust-proof. Here I'm pouring some cellulose thinners or lacquer thinner into the cap of an aerosol can. I want to remove all of the paint from the elbow fitting. In this clip I'm dismantling this old gas tap. It seems to be okay, but I want to make sure. I fitted 2 silicone O-rings to this to seal it, and they seem to be okay, fully intact and doing their job. The cellulose thinners soon removed the paint, and I polished up the elbow using my polishing spindle. I also have another problem. This has nothing to do with the injector. It's the bypass valve and pipe that fits onto the crankshaft-driven pump. I did quite a lot of work on this a while back, lapping the taper plug into the hole using some grinding compound. The problem that I have now, since I ground in the taper plug, is that the hole that's drilled in the plug in the first place is no longer in the right place. And instead of all the water returning to the tank, some of it is being pushed into the boiler, Not much, but it means I cannot stop the pump feeding the boiler. When I last ran the traction engine, I thought it was cracking up because the engine was running most of the afternoon and the water level never dropped. Hopefully the fix will be quite simple. This valve still leaks, but it looks really good. And what I'm going to do is put it in the drilling machine and use a 1/4-inch drill bit to drill all the way through the centre part of the fitting. Why 1/4 of an inch? Well, that is the internal diameter of the 5/16 pipe that I'm using. Before going any further, I used the air line to blow away any chips that the drill left. So this should be okay. It doesn't feel very good though, so I'm going to re-grind in the taper. When I ground in the taper plug a while back, it wasn't really successful because it still leaks, but it only dribbles a little bit, so I don't mind that. I'm going to use Brasso to grind it in to get a really fine finish. First of all, I apply the abrasive and the solvent using the wadding, then rotate the plug in the hole many times, having a look at it frequently. And when both the taper on the plug and on the socket are evenly black, this tells me that there should be a seal. I live in hopes. Back to the other part of the job. I'm cleaning up the flange on some very coarse wet-to-dry sandpaper, followed by cleaning up the flange on a finer piece of wet-to-dry sandpaper. I never liked the physical appearance of this being an obvious gas tap, so I decided to change its shape using my bandsaw. And now it looks like this, so when I refit the operating rod, it should look a good bit better than it did. If you look carefully at this image, you will see I also made a brass washer to fit on the elbow, so this time it's going to be close coupled to the flange, and there won't be a gap wrapped with lots of PTFE tape as previously. I've screwed the elbow into the flange, and now I'm removing the excess Loctite 542 that I applied. I also put some Loctite 542 on the screw that goes in the end of this elbow, so there's no possible way for any air to get into the system here. Time now to fit the modified gas tap with its O-rings and shaped top, and as always, once again using some Loctite 542 to seal it. This was the first attempt. I wasn't happy with it because there was a gap, so I put some shim washers in between the gas tap and the elbow. It's very important to make sure the orientation of all these parts are correct. There's a centre punch mark on the top of the flange over one of the holes, and this denotes that where the centre punch mark is the top of the flange when it's in position on the tank. How do I know this? I went back down to the garage where the traction engine is, and with 4 2BA bolts in the flange, this confirmed that the centre punch mark was over the top hole. By machining my brass washer to just the right thickness, the elbow could be screwed into the flange in just the right position. With the gas tap fitted to the elbow, it's ready to go back on the engine. I'll refit the assembly and see what happens. And that's it for this video. Stay safe and well, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.